I think all the attendees are here. First of all, a very good morning to all the attendees. My name is Sundar Priyasamy, and I'm the Technical Director at Fusion Data. And today we are excited to have all of you here, where we at Fusion Data, together with our valuable technology partner and also technology leaders like Dell Technology, Litmus, Prophet AI, will drive you through on accelerating manufacturing operations through AI. I believe, as all of you are aware, today's rapidly evolving landscape, AI is not just a tool, and we believe it's a transformative force driving efficiency, productivity, and innovation across industry. We hope today's webinar will give you a broader perspective and roadmap to become a successful AI citizens. Just a quick note during this webinar, we would like to have this session as interactive as possible. So please feel free to ask more questions. You can drop down your questions in the chat box. Then later, towards the end of the session, we'll basically address the questions with our respective speakers. So moving forward, we hope today's webinar will give you a greater insights towards the AI journey. And below basically are the key takeaways that you guys will go through from our respective speakers, being it building a reliable, robust, and scalable hardware infrastructure for your AI factory, or even creating, revolutionizing your manufacturing process to become an AI automated factory with virtual data scientists. And then moving forward, achieving everyday AI for manufacturing operation and also adapting and replicating real manufacturing use cases to your environment. So we hope all these key takeaways will be delved through with our key respective speakers. Okay, without further ado, let me introduce our fellow experienced speakers in their respective specializations. We have 4 speakers today. And to start with, we have Mr. Siddharth Joshi. He's a director at Data Center Specialist at Dell Technology, covering APJ region. Siddharth has an over 25 years of experience and is a veteran in data management, cyber resiliency solutions. And he has been with that technology for about 13 years, serving across a range of positions supporting verticals from FSIs, telcos, global accounts across APJ. So currently, he's in the initiative of helping partners and customers accelerating their AI journeys. Then our second speaker is Mr. Jonathan Yu. He's the General Manager of Global Sales at Prophet AI, and has more than 15 years in experience of sales and marketing, and is a very focused and energetic person in empowering industry leaders in designing digital transformation strategies across and action plans for all the manufacturing industries. Moving then, we have Mr. Steve Lim. He's an enterprise account executive at Litmus and has a vast experience of operational data connectivity, OT, for industrial connectivity and factory automations. And towards the end, we'll have our Mr. Edwin Mock. He's the person leading Fusion's data, IoT, and AI solutions teams here, and has a great experience working with digital transformation strategy with customers for big enterprises who are focused in accelerating their AI adoptions in manufacturing. So without further ado, I think I shall pass to our first speakers, Mr. Siddharth, to begin with. Pass to you, Siddharth.
Thank you, Sundar. Let me
You're
just
welcome.
sharing. And if you can confirm if you can see my slide, okay.
Okay, yes, we can see your slideshow.
Okay, thank you. Thank you. Hello, team. Good morning, and thank you for your time and attention today. As Sundar mentioned, I am Siddharth Joshi, commonly called as Sid, and I take care of the data center specialist for channel GTM for Dell for EPJ, and I've been 14 years with Dell now, and close to 30 years experience altogether now. So managing data and security for data. And last few years, we have had this unique opportunity to work with customers through our partners in their AI initiatives. So I will take this opportunity to share some insight around what we have learned and how we have progressed on this. So the key thing I would say is always use case is the key for driving a AI discussion. From a customer perspective, if you know the right use case, it will actually serve you well in your AI strategy. And you may consider use cases that will help you save money, which will help you do things better, faster, cheaper. Or you may look for use cases which will actually transform your business and help you make more business money in your business. And I will share some examples of both of the same. So, of course, typical AI use cases have been around for many, many years. Very simple one is automatic lights coming on. So it is motion detection where somebody comes in into a room and the lights switch on automatically. But that could be a person or it could be a cat, although it will be interesting if a cat comes into your office. But even if a cat enters a motion detection based configured room, the lights will come on. And the next stage of that with some rule based machine learning could be you actually tweak it and put some video detection algorithms to actually find out okay, it's a person or a cat, and then actually use it. Or the further advanced example of that could be in a deep learning based algorithm where you can actually create timeline across multiple streams of video from different camera feeds and use it for use cases such as unidentified unattended luggage at an airport. So you can get a trail of luggage which is there for 3 minutes and there not has not been a person around it for some time, and then you can actually track the history of who brought that luggage in, where it came in from, and all that. So all of the same use case of video detection, object detection can be used in many different ways. And there are even niche solutions further beyond this, like you actually can do it in a GDPR compliant way where you can actually preserve the identity also of the person as well. So as your case might be, there will be different types of use cases which you will need to know for the same technology. Now, of course, within AI, the entire oxygen in the room has been taken away by generative AI today. That's the most popular thing. And like I said at the beginning, simplest use cases today for Gen AI is to actually help people do things better, faster, and cheaper, or improve efficiency, drive productivity, and optimize or lower the cost or accelerate the time to value, right? So you can actually see one example here where you can see you can use knowledge sharing, onboarding, Wing Assistant for many different use cases. And Gen AI actually, a same single model can actually help drive many of these use cases with the customer today. However, the interesting part, I believe personally, is the ability for Gen AI to transform businesses and allow you to make more money as well. So now we are seeing use cases where traditional AI or predictive AI and Gen AI are being used together to drive revenue and create a campaign. I'll give you a couple of examples. One very popular one within FSI or telcos is to do next best offer and couple it with custom campaigns or outreach campaigns for their HNI. So let's say you are a bank or a customer, you want to reach out to your target customers within a subset, which are a subset of all of your customers. You actually get that information from a simple predictive AI model, and then you pass that information to a Gen AI model to create personalized campaigns for each individual based on their characteristics identified from the predictive AI model. And this can help accelerate. So typical examples we have seen where companies were able to do campaigns or promotions or ad revenue marketing events in 3 to 6 months. Now they can do it in as small as 2 days or a week, actually. That is one very interesting one. Now, the more creative example which we saw and worked with one of the customers is actually where a telco and a retail company came together, and they both stand to benefit from them, and both with explicit permissions from the customers, their customers actually able to leverage. I can give this as my own examples, my coffee drinking habits with my telco using my GPS data to actually know when I am near a cafe, and the coffee company actually making me an offer in real time when I am within a 50-meter radius of their store. So the telco stands to benefit because they have a revenue share agreement with the retail company, cafe company, and the cafe company gets to leverage their my buying history with them to make me offers and actually make sure that I consume the beverage from them rather than from somewhere else. So this kind of real-time processing of data is now possible, and there are many applications of the same, even in OT as well. And I think Steve will talk about some of them, but we can actually take OT data and take business decisions on this in real time as well. Another one I would like to share is around manufacturing, where we are able to help customers move from a schedule based maintenance cycle to a condition based maintenance cycle, thereby either prolonging the life of their equipment by actually attending to the maintenance as required based on the actual condition of the equipment, or even delaying the maintenance when possible if the machine is operating well within the parameters they define, and you can actually defer the spend, thereby saving money with this as well. So this has been very successful, especially in high cost equipment manufacturing like oil and gas, where the drill bits are actually diamond heads, and we were actually able to showcase this to a couple of oil companies as well. So there are hundreds of use cases you can always do, and there are different use cases. But we will look at. I will try to share some of the considerations we see in terms of which to pursue and how to pursue. And what I like to use is this framework, which we created after our engagement with 50 plus customers around the same conversation. So what we try to do, if you see the elliptical structure at the top, we try to identify the use cases which have the highest probability of value and the best chance of feasibility of success based on whether the data is available, the right model is identified, does not impact any business process change, and people can accept it easily. All of those and deriving high value, which is higher ROI, we actually tend to cluster them together and then try to adopt those use cases. So that has been our experience where customers try to do similar use cases which have high value for them, and they will be able to execute quite simply with reasonable amount of ease regularly. And that is those are typically the ones which do not require large behavioral change or process improvements or modifications, and allows the data access to which where the data is typically within the control of the organization or easily accessible, and to be more transformed and morphed into the AI model. So if I were to summarize from an approach perspective on the use cases, customers need to consider what is their vision. Are they doing exploratory AI, or they are looking at AI more strategically and want to adopt it for their entire enterprise? After that, they should try to identify the key use cases which fit their existing process and easy for them to justify the ROI on that. Plus, the important thing is to know what technology stack and what partners like Fusion Data can actually help you provide the necessary skills and the infrastructure and the support required to execute this project. Because typically in an AI project, there are multiple stakeholders involved. There are different types of technology stacks involved, like Kubernetes, cloud native architectures, specialized infrastructure, specialized storage, and different operations and maintenance skills required, which you need highly skilled partners to help you execute the same. So if I crystallize the entire discussion from an AI life cycle, this is what it will look like on a one slide. And this is again a high level slide, which is a bit of an oversimplification. So please take that into consideration when you try to repeat this. But at a very high level, there are three blocks which you need to manage and deal with in any AI life cycle. Starting on the leftmost block is where all the grunt work or the heavy lifting needs to actually happen, where your 80% of the effort is required, which is the data engineering piece. So this is about sourcing the data, collecting it, cleaning it, padding it, making sure it is clean, consistent, and accurate, and then transforming it into the format where your model can actually consume it. AI models cannot consume RDBMS, cannot consume MPEG files, JPEG files directly. They all need to be transformed into open data format, into streaming data, or open table formats where the actual AI model can actually execute on that. After that, you come to the AI model block where the customers typically have to make a decision between, do I buy the model off the shelf, where many off the shelf technology is available, either closed source or paid, or open source model with the right level of support. And both of them have their pros and cons, but open source models are typically more useful for enterprises because they allow for greater degree of customization and allow you to run your business critical information in an internet disconnected way while offering all the same capabilities. And then you might do a second option is to build your own model from scratch, which you would rarely need to adopt unless you are doing a very specialized use case which nobody else has really solved. Now, after you've been through the first two blocks, is when you actually come to the real part where your value starts accruing, which is the rightmost box on the chart, which is like where the model actually gets deployed into production and you start using it in your enterprise. And there the considerations are whether you will supplement the existing solution system you have in place, or you will replace the system with the AI system. Typically, there is always a parallel run. Customers will actually try to supplement the existing system, and then eventually after they get comfortable with the AI model operating at a rare degree of certainty, then they may regularly switch that off. But unlike traditional database workloads or application workloads, AI workloads need to be monitored not just for functionality, but for model accuracy, which does not exist in traditional workloads. So you need to actually make sure you are tracking and managing the model performance day in day out, every transaction, and making sure it is within the acceptable error rate, or the model may be giving undesirable results which you might be using in production. So that becomes very key, and hence ML ops or machine learning operations has a very key role to play. And that will also advise you at which point in time do you need to review the model accuracy, which point in time do you need to replace the model or upgrade the model or do any changes as required for the model to continue to perform. Now let's look at how we help you in all three of these aspects on an ongoing basis. So like I said, the data problem is probably the highest heavy lift or biggest heavy lift in the entire AI cycle, and it is well documented across multiple studies. The one I'm referring to here is from Forbes, where almost 80% of the data activity has to be done before the actual AI model comes into place. And that's where you do the data set development, identifying the data architects will actually try to see where the data is, which patterns to collect, where to get the data sets from, organize it, and then clean it, filter it, patch it, make it into a consistent time series across different data sets so that the model can have a unique reference point of them at each point and is consistent, and then refine the algorithms to actually start testing and training the model and then start deploying into the production. Now, this is for one application. Try to do this in an enterprise. When you actually adopt it strategically, you might end up doing this to 20, 50, or 100 times, depending on how many different models you apply and you actually start utilizing in your production. So this becomes a very complex problem. And I can share one example where a very simple machine learning model uh, was deployed, which was a linear regression model, as you can see in the second box from the right, which is the machine learning model, regression model. But you look at the sources of data coming from different parts and different departments and different BUs managing it across different points in time. This is a very simple use case of crop yield estimation, and countries which this was done, they have been doing farming for hundreds of years. They have hundreds of years of historical data, so they can actually know very well. But getting the data in the right format for the model to consume was the bigger challenge for them. And that's where you can see they were having satellite data, they were having weather data, they were having drone high resolution image data from the drones. They had satellite image data as well. They also had Excel based data and farmer self declaration. So all of this data is generated at different points in time, different amounts of data or data points, and in different formats, which are none of them are directly usable into the AI model. So we actually help them with a data lake solution, data lake house solution, which allows them to convert all of this data in real time and unify the stack, apply all the security and governance required around this, and be able to actually reduce data movement. So all the data can be accessed from the source directly and can be transformed, consistent, patched, whatever changes need to be done from a ETL or ELT perspective, and be made available to the AI model in a data product format. And we offer this as a open scale out architecture in an appliance format, so the customer is ready to use day one. When the appliance gets shipped, they can actually directly start connecting it to data sources and start using it into their AI models. They don't need to do any setup, they don't need to configure any hardware, they don't need to set up any Kubernetes platform or a query engine to actually set up and start processing the data. They can directly get to the business end of thing, really simplifying the 80% of the activity required, and do this across multiple enterprises. So you don't, when you set up a data management platform or a data lakehouse solution, all your data pipelines can be collapsed. You have single source of access and single source of truth for all your data, which can be managed and secured and governed at a table level. So you can actually, one of the key worries people have when they go for Gen AI use cases is how do they maintain control at a table and a row level to data which can be accessed. Like one of the common use cases we see in enterprises, as soon as you train all your data in an enterprise and publish it, make it available via a large language model, people start accessing, directly asking for, well, how much is the CIO salary or how much is the CEO salary? And you can restrict that kind of access to the data at a table or a row level with a lakehouse solution, modern lakehouse solution actually. And that addresses your data management platform requirements completely. The second choice which customers have to deal with, which we talked about in the second box, was in the model building space, whether they actually choose to buy off the shelf models. And there are 200 or 300 ISVs available in this space itself within APJ as well, who are offering product solution, use case based solutions and support, or they can go and build their own models as well. Now, from a Dell perspective, we have actually classified these partner ecosystem into different kind of categories, and we work with many different tools and platform providers to actually provide all of these services seamlessly for you to execute your projects. This might be auto code, low code, no code providers, or IoT data providers like Litmus in the call, who will share later, or can be platform tools like run.ai, clearml, etc., which allow you to manage your AI platform and simplify the tooling for the same as well. However, if you do go down the path of development yourself and building your own model, we believe you will still start with some pre-trained model, and you would need assistance during the model augmentation or the RAG kind of solution or the fine tuning kind of approach. And that's where we have teams and skilled, capable resources with partners who can actually help you with this as well. Now, the last part I want to wrap up with in this conversation is to summarize the thinking which we have discussed just now in terms of what it will take for you to actually embark on an AI journey and how it will be successful for you. Obviously, please do note that there are the feasibility versus ROI considerations. So, what use cases are you going to do, and what kind of budget you need for this? Because they need specialized infrastructure like GPU servers. You might require particular types of storage. You may require specially skilled services to be engaged, or you may need to build models and do some different activity from what you're being managing IT infrastructure now for. The other capability is who will be your partner in this, so they can offer you, like I said, across the entire journey, data science capability, data management capabilities, model building capabilities, and running it in production kind of services. So what capabilities you already have and what skills you would need to acquire and who will supplement those skills for you is the last consideration. And then the last part, this might sound a bit contrarian to some of you, is in terms of the data part. Now you might have the belief that yes, you have access to all your own data. Definitely you do. However, your AI models may have dependency in terms of external data sources, which might be like a sentiment analysis use case where you are dependent on what is being sent about you in mainstream media or social media, or it might be regulator dependent data which might be published by your industry regulator, or benchmarks outside, or competitive data which you may not directly have control of. And those data may have a different implication on your AI project as well. So please make sure when you're designing the system or when you're embarking on the journey, take these 4 areas into consideration. From our perspective, and this is my last chart I wanted to share, how we make you successful is actually by starting with the use cases which you saw, and those actually drive right back into the data part, whether your data exists on the edge, whether your data is in a data center, or your data reside in a cloud. With a data lake solution or with a platform which we provide, you can actually access all your data, whether it is on your edge, whether it is in your data center, or it is in public cloud, multiple public clouds. You can actually feed all of that. We actually are one of the few OEMs who can actually provide end to end all kind of capabilities like NPU based laptops today, where you can actually load a model on your laptop and deploy it and test it and real data, and then push it to production, so all the way to compute, storage, protecting your data, protecting your code, networking around it, and actually having the framework to manage all of it together. At the same time, we work with an open ecosystem where you can actually choose to integrate with model building ISVs or use case provider ISVs or different frameworks and tools, and across having the ability to use specialized AI infrastructure from different vendors as well. We don't tie you down to a particular OEM or a particular hardware provider as well. And we have teams for cloud native architecture, we have teams for data scientists, and we have a partner ecosystem which can provide you specialized skills that are required across the entire organization. So that's where we believe, and this platform, our approach is called as a Dell AI Factory, and we believe these factories will help you be very successful in your AI journeys in your manufacturing use cases as well. Thank you. And any questions for me to address? I will definitely have a look at the chat if there are any active questions, but anybody wants to ask a question, please feel free to ask us. While they do that, I will pass it back to Sundar, please.
Thank you. Thanks a lot, Sid. That's a very resourceful presentation, I believe, as Dell show us how Dell technology approach towards AI factory with insight of use cases, AI life cycles, Dell Data Lakehouse initiatives. Then that's a great one. So moving next, if any of the audience has any questions with regards to Sid's presentations, please feel free to drop your questions at the chat box. And then moving next, I think I shall pass screen to Jonathan. Back to you, Jonathan.
Hi, Sundar. Thanks. Just want to check, is my screen clear and my voice?
Yes, you're pretty much clear. That's it.
Okay. Thanks, Sander. So it's glad to have this opportunity to introduce Prophet AI in our solution to all of you online. And I'm the general manager of Prophet AI's global sales team. And today we're talking about citizen AI strategy. So this kind of concept has been bring out by Gartner since 2016. And right now we see lots of manufacturing customers are willing to adopt this strategy to make AI more accessible. And it can be more user driven by different kind of function and different kind of user to build their own model. So it's more like a self-analytic approach. And we see like right now, lots of our customers are moving forward to this kind of strategy. And the technology that we provide is a very easy to use no-code platform, which is called virtual data science platform. So we will talk a little bit about our technology, but today we'll focus more about some actual use case and some of our successful stories. Okay. So Prophet AI, we are established by a group of experts who used to work in IBM, SAP, and PTC. So we have 20 years of experience in software and also manufacture. So right now, like Taiwan and AI is trying to make a lot of difference in the ecosystem, and we're starting to doing lots of global expansion. So Taiwan right now, we have more than like 10,000 of AI technical and application which are produced every year. So this is why we think that we can share some of our experience because Taiwan is moving very fast in AI. So we also partner with Jensen and NVIDIA, and we are stated by Jensen that we are their close partner. So you can see like Taiwan has lots of ecosystems starting from component and module and assembling and even AI technology and software. So we have like a clear roadmap, and those market in the green square are our customer, which plays a very important role in the AI ecosystem. Okay. So what we have done right now is we have more than 230 customers that are adopting citizen AI strategy. And there's our two index that I would like to share with all of you is the model per client that we see in the enterprises right now is 45. So what does this index mean is traditionally, if you want to build 45 AI projects, it will spend a very long time and it's nearly impossible unless you have a very big data science team. But right now, because of the easy to use virtual data science platform that we provide, it is very easy for the end user to generate model very quickly. And so some of the customers, they even have more than 50,000 of AI models that are built on our virtual data science platform. So it's a very large amount. And we already collect thousands of use cases. So the trend in the environment has changed a lot. Now the user will trend to want to use like new technology and tool instead of they're just doing the Python in the code starting from scratch. So this is right now, we can see like a lot of the customers and some of them are IPO customers. They are starting to do lots of the works on citizen AI data science. So here's our in different kind of industry. So right now we have built like a very strong reference in different kind of industry, starting from semiconductor, PCB, or even more conventional industry, such as like paper manufacturer or like retail or even basketball club. They are all using citizen data science as their very important strategy and vision to drive more and more AI model in their factory. Okay, so what we see will change is in the past, you can imagine the factory. I think this is like if everybody will belong to the factory and the manufacturing side, we can see now in the past, most of the operation of the factory is highly based on the experience. So it means that we use human in their knowledge, in their experience to oversaw the whole operation. In that case, in the past, it might work. It's because the employees' stability and the quality is very high. So some of the engineers, they work in the company for more than 30 years and they retire there. But in the future, we can see that the stability in the employees' quality might not be as good as in the past. So lots of the factory, they are going global. They move outside China or outside a different kind of country. So you will have lots of freshmen and intern and foreign workers in different kind of region, or even you need to interact with the robots. So you can imagine that these portfolio of the your employees, they don't have lots of experience. So they will do lots of try and error, and it's very time consuming for them to operate their manufacturer. So for example, they have lots of questions in R&D, how to shorten the R&D cycle, how to reduce the try and error cost in the NPI, new product introduction process, and how to improve my quality level, how to very quickly find out the root cause, and how to detect the anomaly before the equipment actually broke down. So in the past, because you have lots of experienced workers, so they can solve all the problems suddenly. But right now, if you don't have that experience, it will be very important for us to build different kind of prediction model that right now I just stated in the green color. So now we have lots of data and different kind of process. We use the data to build prediction model to help the user as a decision supporting system to operate different kind of function. So you will have different kind of model and different kind of process to help you to make your operation better. Okay. So we can now look at, there's still several challenge when the customer, they are adopting AI, and this is what Prophet AI, we together with Future Data, we want to achieve. Is the first one is, as O'Reilly has stated, there's lack of skilled people in hiring the required role. So it means the job of data science or like data engineer. It's not very easy for them to hire. And we always face like a very big challenge about how to choose the correct use case. So most of the customers and the enterprise, they want to choose the correct use case, which we can just got the ROI very quickly and they can mitigate the risk, but they don't know what is the correct and the appropriate use case for them. So these are the top two challenge that O'Reilly has stated. And about the McKinsey that they stated in a like very popular document, which is called the State of AI. They said that the high performers and the other respondents, the difference between them is how to develop a very clear priority of what you should do with AI, and it should link to your business value. So these are the three aspects that Prophet AI want to solve. And the first one, we're talking about the virtual data science platform. So it's like we put all the technique and all the skill and algorithm that the data science they previously built from scratch all into our platform. So they don't need to struggle with the code. So this is how we tackle the challenge one. So we build our end-to-end no-code platform, which is very easy for the end user itself without any technical background. They can quickly generate the model. So for example, if I have like a machine data, which is like an Excel file or even CSV or database, I simply just prepare the data set. And then I just upload the data set into our prediction model in our platform. The platform can be very easily, you can use only 5 steps. You can start it from building the prediction model very easily, and then do lots of simulation in the manufacturing line to do in the R&D phase or the MPI to quickly to generate the result and can reduce the try and error effort. You can simulate before you actually put the parameter in the manufacturing line. And also it can do a very quick optimization to find out the golden recipe in the parameter in the equipment. And the last one, it can do lots of data exploration to find out the correct scope or the spec for different kind of factor that you want to control. So this is a very easy to use platform that we let the user to focus on their domain in their problem. And we just take care of the rest of the Python and the coding. Simply just put all the things in the platform itself. Okay. So for example, machine learning is a technology that we use. It will start from preparing the training data. So the training data is like a data set, which you have lots of parameter, which is might be like x1 to x3 or xn. And you have some result that you want to predict, which is y1 and y2. First, you predict, you prepare the data. And then what we have inside is we have lots of already established algorithm. So for some of the power user, they can simply select the algorithm that they want. So they don't need to just build it from zero. Or if you are the domain user, you can simply use our fully automated function. They can choose the best one for you, and you just don't need to choose it at all. So after that, you can come out the model and you can do the prediction. So this is the whole process. And the part that we want to simplify is the coding part. And we already include lots of algorithm. Okay. So in the past, we will spend lots of time after we define the problem by the user and collect the data, and then it's the manual coding. Okay, and right now we only will spend about like 1 or 2 weeks. It's a lot of difference between in the past because we need to do lots of coding. It might last for 2 and 3 months. Now after you collect the data, you just do the input. Only like 1 or 2 weeks, and you can come out the result. So it's a very fast and very cost-saving approach. So we have lots of key function. I won't just go through like very detailed. We start from how to upload a data set and automatically build a model. We already include like 50 to 60 different kind of algorithm, and then you can do the validation. And after that, and you can find out the root cause with the feature importance function and do the prediction and the optimization. So these are only 6 steps, and you can finish your data science journey. And the second one is how we tackle the difficulty of identifying the correct use case. So we start to collect different kind of scenario that we see in a factory. So for example, for factory management process, 4 of the aspect that our customer use a lot of our platform is from optimizing the process, find out the key parameter, and how to do the quality prediction to reduce my inspection man hour or the equipment cost of the inspection machine. Also, the equipment diagnosis and the recipe design are 2 important functions. Like equipment, we can just do a health check for the equipment. And also the recipe design is some of the petrochemical and material customer. They will do lots of design of different kind of material, and they want to shorten their cycle time when they're doing lots of experiment. So these are the 4 that we see a lot in the factory. And the right side are 4 that the data might come from the ERP, including the sales and marketing, how to do the forecasting more accurate, how to use the human resource data to predict and estimate the probability of certain people will leave the company, and I can do some action. And about the inventory and the supply chain management, which is a hot topic, how to control the inventory level very good. And then about the purchasing and pricing, about some raw material. We want to use some external data in some previous procurement record to find out the price trend for the future. So you can even try to do a price prediction and just try to purchase the material at the right time, which the cost is the lowest. So what Profit AI started to do is we see no vendor has do it in the market, is we started to collect a different kind of vertical, like EMS, PCB, semiconductor, and panel. What are the use cases that they commonly use? And they found out it is really productive. So we started to collect all the database with our consultant. So you can see different kind of process, for example, for PCB, the E&I and etching speed, and also developing, and also the solder balling. These are very important manufacturing process. And we have some experience and we have done with them. And we found out that these topics are some topics that with very good ROI. So we can share with our customer. So in that kind of approach, our customer can quickly find out what they want to do. And we can share with them how they use our platform to achieve certain result. So we did a lot, which we call ready to go application, and we built it upon our platform. The third one is about how to develop a clear strategy. So we also not only implement software, we also have a consultant team to help our customer to onboard. So the first one is we establish AI mindset and skill, helping our customer to select the right people and do the basic training, and for them to understand what is AI and machine learning and what is their expectation, what is their limitation. So it's from the short-term AI workshop. And then we also integrate AI with their process. So our consultant team, right now, we collect some pain point and also analyze and discuss with the customers. And we can just diagnose their process and find out what is their pain point and what is the topic suitable for machine learning. So our consultant will do some problem solving with a customer and then create the AI brain and the decision supporting system for the enterprise. So these are our steps. And after the workshop, we can have lots of AI enabler. So these are different kind of functions user, which they are the domain user and they are the seed. And after they know the concept and they have the tool, then they can generate lots of AI application in their process and their daily works. So lots of our people and our customer are asking about, they are using like lots of DOE technology, and also what is the difference between machine learning. So here I provide a framework for all of you that right now you can see one is the feasibility of data collection, and another at the y-axis is the degree of the clarity of the relationship between feature. If the feasibility of data is really low and you don't know relationship, we should start from DOE. Because we have no data, there is no machine learning. Okay, if we have some high data collection and we also have lots of like data, but we don't know the relationship between the factor and the result, we can start to use machine learning. So this is the B is a good way to start. And if we still have like a very low feasibility of data collection, but we know the correlation, but we don't have data, you can do some simulation with some small data and start to digitalize data and then do the machine learning. Okay. And the last part is A, which is can be hardly been done. It can be using Gen AI and deep learning, where the relationship is clear and the feasibility of data collection is high. That will belongs to A, and we will encourage everybody can do some study about the Gen AI. So the next part is some customer reference that we already did. Okay, so the first one, I'll start with one of the very famous factory, which are stated as the WEF, World Economic Forum. They are the lighthouse factory, and one of the best in the world is AUO. So they have 38,000 people worldwide, and they use our solution to help the non-IT department to develop multiple AI applications. So by the citizen data science concept and culture, they reduce the factory manpower by 20% and improve lots in the efficiency and shorten the cycle time, not only the R&D and also the quality inspection and also the manufacture. And they accumulate a lot of the cost reduction, over like 300 million. So these are stated by their PR department. It is open to disclosure. So they use our solution and to develop lots of different kind of model every year. So you can see they develop over 1,000 of model using ProfAI's auto machine learning platform. 38% of the project is about how to improve the efficiency, and 38% is about the process, and 10% of the case is about the equipment maintenance alarm and do the self-check for the equipment. So they did lots of model. So they have an internal vision about AI for everyone. So leveraging lots of the domain user to have the no-code platform as a tool to help them to improve their process. But absolutely, they have like a journey. So it's not been done by a blink. So they start from 2018 by process optimization and automation, and then they start from training in 2020. After the training, after the workshop, and they provide the virtual data science platform to them, they can start to do lots of predictive, and then even scheduling, and also the whole manufacturer can be full automated and using ProfAI as a decision supporting system. Yeah, to get out the correct recipe and find out the root cause. So traditionally, they're using DOE, parameter optimization, which will cost them like 1 or 2 months. And right now, after they confirm the data quality, and they use auto machine learning and the recipe design to get a result within like 3 days to confirm the outcome. So it's a very good approach for them to find out the root cause, and they can do the whole process like very shortly. So this is one of the example. It's a process which is called the water jetting in the LCD manufacturing line. So you can see they use the traditional domain knowledge to try to continuously do the improvement and to just lower the defect density. But they will have like a limitation of like 0.17. And then they started to use some traditional analytics, which is jump and Minitab, to just continue to improve and get it lower and lower to 0.12 and 13, but then there's a cap for them. So they want to find out more and more key factor, and they have lots of data to analyze it to keep improving. So then they use the auto machine learning to keep it down to 0.04. So there's a lot of improvement about a stretch down in the years up. So the manufacturing process is mainly 4 different kind of process, starting from detergent, and also they use the pure water and pressurize from the upper part and the lower part, and then the water jetting. And then this is the outcome of the process. So although you can see only four different kind of process, but they have hundreds of parameter inside. So they don't know how to improve. So they all want to find out the key factor. So ProfAI's platform can very quickly, we can just come out the key factor. So you can see the bar chart. They have hundreds of parameters, but what is the one that will improve and it will affect the scrap rate? They can find out the root cause, which is the highest bar, and then they can do the optimal parameter optimization using our platform. How to do the parameters optimization, and our platform can come out. The 59.4 is the actual value, and it's the best value for you to adjust your circulation shower flow. So this is the parameter that is very important for them. So you can see this is a very easy approach. Simply just put the data inside, find out the key factor, and optimize the key factor and come out the recommendation. So this is a real case I can share. Another case is BenQ, which is a very famous projector and also mouse and also monitor company in Taiwan. So we help their factory to quickly to reduce the scrapping of the production line and to reduce the material waste and improve yield, because they have lots of different kind of product that they need to manufacturing every day. So they will have lots of loss when they need to change their line between, like, you want to switch from producing A product and then to B product. So they want to shorten the cycle time when they are changing the production line and change to another product manufacturer. So they use our perimeter optimization so they can quickly come out the best factor, and then they can just change the line. So it's a fast changeover method, and for them, they can just save lots of different kind of costs because the changeover time is very short and you can reduce the material loss and the labor hours. And they even did some like a very interesting use case, which is not actually related to manufacture. So they use it as a spare parts management. So some of their supplier might tell BenQ that certain parts might be like the lens or the motherboard, they won't support it in the future. So for BenQ, they need to do a prediction. They want to buy all of the future demand of the parts in the 3 to 5 years. So they use our prediction model to quickly come out the result of how many parts that they will be needed in the future 5 years, and they can do the one-time procurement to lower the cost. So this is like one very impressive case. And another one is the freight index, SCFI prediction, because they want to know what is the future trend of the freight index. And I want to lower the cost, and I want to just arrange the shipment at the right time. If the freight index cost is going up, I will just want to do the planning of the shipment earlier. So to optimize their cost and inventory. So this solution can be used in different kind of aspect, not only the manufacturing and also the supply chain or even the freight index prediction. So these are like very useful use case. Okay. They even can be used in the chiller machine. So this is a very like popular topic in semiconductor, because they want to compliance with the ESG standard, and also they want to lower their energy saving. So this is a case that they did is by first they use the perimeter about the temperature, chill water, and the equipment signal to forecast what is the actual refrigeration tons that you will need in the factory for the next 12 hours. So this is the demand. Okay. After they know the demand, they want to find out an optimal chiller on-off combination. So they want to know like what is the combination that I should put on the chiller machine, what chiller machine that I should put on to fulfill the RT value of 1,600, but at the same time will have the lowest energy consumption. So by our platform, they can do the chiller combination. So if I want the target to be in the next 12 hours, I should have like 500 RT. This is the demand. What is the combination should I open? So combination A is chiller 1 and chiller 4. You just activate it together. The B is chiller 2 and chiller 5 activate together. So these are 3 combinations. And our platform can come out what is the best in terms of the energy consumption. So you can come out the best, and it still need to meet the target. So this is the combination that they did in the recommendation. And the third one is they can adjust the chiller setting by using our platform. We can come out what is the best setting parameter for them, and they can just quickly adjust the parameter in the chiller machine itself. So this is my last page. It's about Aecon. So this is a very significant case also, because we have worked with them and they have now 1,000 different kind of like transformation talent that are using Prof AI. So they really established a very good citizen AI data science platform and strategy. So they have done over 100 of platform use case. About like 470, they use it, and they have been adopted within 1 year. So the secret is they let lots of people to get trained and use the platform and find out what is the key topic that they want to solve. And they have a very good KPI, which are established by the chairman, that everybody should have some improvement every year with the no-code platform. So the result is pretty huge. And they are stated that they have already saved like more than 2 million USD every year by these 470 different kind of projects. So thanks everybody. So you can welcome to follow our Facebook and LinkedIn. And here are my contact and email. And you can have like some information, more information on our website. So I'll just give the mic back to Sander. Thank you.
Thank you, Jonathan. I think it's a very resourceful presentation where you started with AI citizen strategy, then you have shared use cases in different industries respectively. Then you have also shared challenges and where and how Prophet AI Auto ML solution with virtual data scientists basically able to create resourceful use cases. Thanks for a very detailed use cases from so the respective customers that you have gone with. So I believe it will be a good insight for all our attendees today. Please feel free to drop us questions on this, and if you have any specific question or any discussion that you want to follow up through after the session, please drop us an email as well, then we can follow up with you. So moving forward, let me pass the next speaker of ours with Mr. Steve. I'll pass the session to Steve. Back to you, Steve.
Hello. Can everybody hear me?
Yes, loud and clear, Steve.
Okay, good. Hello, everybody. Thank you for joining the event today. I'm Steve. I'm actually the Enterprise Account Executive based in Singapore. So I'm representing Litmus today. So just as a brief overview of our company. So we are a US-based company. We have offices in Silicon Valley, Toronto, Munich, and Tokyo today. And our technology focuses on industrial data operations, right? So when you hear things like data issues, data pain points, data pipeline issues, and especially what Dell Sid has mentioned about, in order to enable AI, you need to have the data is not immediately ingestible by the machine learning models and AI models, right? So for Litmus perspective, we provide the tools for you to actually clean the data right at the edge before sending to the consumers of this data, right? So that's what we call it as industrial data operation. And for us, for Litmus, we are very focused on industrial, right? So our platform is designed and purpose built for industrial adoption. So that's the product and our technology in a very high level view, right? And today, we have a couple of customers that thousands of customers actually across the globe that's leveraging on Litmus to provide that data pipeline for AI, or for traditional KPIV real-time dashboarding and things like that. So this is a snapshot of our customer portfolio today. So you can see that our technology is actually quite horizontal, right? Because when we talk about industrial, there's batch processing, discrete manufacturing, continuous manufacturing. But when you look across the technology stack, typically they are generally the same, right? You have your control systems, they follow the ISA 95 standards, and that's why our technology is quite horizontal. From some Dell perspective, again, we are also a OEM partner of Dell. So after the show today, if you're interested, reach out to Fusion Data, and then you can actually find out more about how each of our components work together, right? So in a very broad sense of what Litmus does, right? We allow you, like what I say, to perform the industrial data operation. So right, the word industrial typically refers to your operational technology component, right? So things like your PLCs, your sensors, your SCADA systems, your MES systems, and even the ERP systems, right? These are all potential source of data in the shop floor. And these are all the different components that keep the factory moving. So from Litmus perspective, the first phase, right, where we focuses on in providing our suite of operation is to unlock the data, right? So when we talk about unlocking of data, typically we're talking about data collection, or rather the drivers. So out of the box, Litmus provide you over 250 sets of different protocols and drivers to connect to the machines itself, right? So once the data is collected, right, we have the data. The next stage that Litmus allow you to do is to contextualize that information, right? It's important to look at contextualization, because today, right, when we look at a lot of our IoT projects and customers pain point them when they describe the issues, a lot of the issue with them is that they were using solutions today piecewise, so maybe 3 to 4 different solutions to do this whole stack. So they may have a software to do the collection of data, but they did not do the contextualization, right? So the raw data is then sent directly into a SQL database. And what the customer have realized is that as the scale of innovations and transformation is taking place, they ended up with more silos of data because maybe project A collected this data and they put it in this particular SQL database. Another project came in, they ended up with another database that requires the same set of data, right? So they're replicating the same set of data across the board. And they might be even doing the same analytics, same calculations of PIV, but presented in a different format. So from Litmus perspective, once we have the data, we contextualize the data, right? We allow you to perform analytics. So out of the box, Litmus is a low-code platform that allows you to do your analytics to calculate traditional KPIV value, as well as we have a component called Flow that allows you to do more custom analytics and scripting. So the last phase that a lot of the customers, when we talk to them, that they did not think of is scaling, right? So for example, if they have one solution built for one line, how do they scale across the entire factory? How do I go beyond one factory and go to 3 or 4 different factories in the same region or across the globe? How do I scale, right? And so that's something that sets Litmus apart, in my personal opinion, is the scaling components, right? So Litmus actually provides you the capability to scale by blueprinting the solution that you have built and roll it across the factory floor. And on top of that, we provide a full orchestration of the age lifecycle management. Right. So when you think about cyber attacks and all that, it's important to have some form of mission control components to ensure that the fleet of software that you have deployed are running at their latest patch and they can be mitigated if, let's say, there's any situation. It can be recovered, it can be backed up. All these things should be in place when you look at a platform perspective. So, from industrial ops, when we talk about industrial systems, typically these are all the key components in the industrial systems, right? They are typically, from siloed into different brands, right? Depending on how your factory is started up. And you may end up with a couple of brands as your factory starts to go into production. You localize some of your supply chain. Some of your maintenance are from third-party sources, or even because you have seen certain solutions that you think might work for your factory shop floor, and you introduce it to the environment. So when we look at the OT side of things, right, it's typically, there's a couple of different components, and it's very complex because there's different components that does different things, right? And now with all the technology coming in from the IT side, how do we marry both of them, right? How do I get data from OT, make it an ingestible and digestible format that is easy for the IT team to take and do what they need to do, right? How do we introduce technology on top of on OT technology, without interfering their operation, right? If you think about it, OT, when we talk about operational technology, the key focus is to ensure that the plants have no downtime or zero downtime, right? Efficiency and availability. These are the 2 key things that they want to do. So how do we introduce new technology? How do I get the data from all this technology without creating additional stress on the OT team for all the digital operations? How do I help them with that? How do I get both teams to work together? So that's what Litmus aims to solve from a data perspective. So when we look at what Litmus does, right, we take an edge-first approach into our industrial data operation platform, right? So when we say edge, right, what we mean is that it makes more sense for us to do all this data cleansing and data operation right at the edge, right? So to deploy that in your shop floor, and with over 250 drivers, we can actually quickly take up the data. You may already have, your OT may have already standardized on things like OPC UA. They may have pockets of data points from legacy systems that are not connected, right? We can also ingest those data. So new technology, old technology, we can actually try to help you to collect the data right into the platform. And then once it's inside, we allow you to contextualize the data. So when you get the data from OT, typically they are flat in hierarchy, right? So they are flat data. What we allow you to do is actually through a module called Digital Twin to create a data structure to help you create the hierarchy for you to visualize the data more efficiently, right? And once that is done, you can actually run machine learning operations. So for example, in our earlier speaker, we have Prophet, right? So let's say when they have finished the modeling, you need to run that workload right on the edge. That's where you can actually leverage Litmus to do it, because we allow you to host your containers and integrate into the industrial connectivity to run real-time machine learning operations. Right. And once all this data and is done, you need to send it to enterprise integration. We have built-in enterprise connectors to allow you to actually push into different consumers of that data. So it could be an AI platform, could be a cloud platform, could be that you have a BI tool, or even nowadays there's a lot of discussion about the distribution of data governance on UNS, right? We can and single source of truth, like what C also mentioned. These are all components and technology that we can send out to. So customers choose Litmus typically because of the number, firstly, because of connectivity, right? Firstly, we must have the data. So that's the first reason. The second reason that a lot of customers like about Litmus is that when we talk about our solution, we provide the full stack of solution. It's not one part of it, it's not one piece of it, it's the full stack. We provide the data collection, the analytics, the contextualization, the distribution, and even the connectors, right? Completely within one. So customers who eventually adopted Litmus can replace 3 to 4 different software with just a platform. And that also means that when you have issues, it's easier to do troubleshooting. There's one vendor that manages all of this. Right. And the last thing that I talk about is the scalability of our platform, right? We have the Litmus Edge Manager that does that. So this is a snapshot of the breadth of connectivity we have. So for if there's any OT team here, they can recognize some of the brands. For example, we have Siemens PLCs, we have Mitsubishi, Siemens PLC, Mitsubishi PLC, or you may not want to go to that low level. You can use OPC, right, to connect to the SCADA systems. You can also connect to building systems, right? If you have in a semicon, you want to connect to the chiller systems, you can also do that. We also have the more generic industrial protocols and Modbus that allows you to actually connect to more generic things like power meters, sensors, and so forth. So when we talk about contextualization of data, why is important, especially in the context of what the show today, right? We're going to talk about AI, right? The biggest challenge for OT, right, when you take the data is that it's flat in hierarchy. So if you look at this particular screenshot, right, we have on the left is actually how the data looks like in the Litmus platform, and on the right is how typical OT solutions like OPC servers look like. So if you provide this sort of data to your AI team or even to your developers, right, chances are they are going to have a very hard time to understand what this data point is about, because there's no relation, there's no contextualization, there's no metadata around this, right? Anyone who looks at this data, right, all they can tell you is that, oh, there is maybe a temperature point, there's a set point, which I don't understand, or it could be in this weird, not weird, but in the OPC format, channel device tag. So things like this. It's very hard for the developers, especially when we talk about citizen developers. You want to enable your internal talent to be able to take this data and do something cool with it. It's very difficult for them. So from a Litmus perspective, we provide you the tools to contextualize. So when we say contextualization, right, we actually have a low-code platform that you can see from here that allows you to click and drag. So this is entirely click and drag to create that data structure, right? Once that data structure is done, you model it. You can actually then fill up each of these parameter with the actual data points, and the result, right, is actually a cleaner JSON-based data that a lot of developers, when they see this, they can actually take this and go and use it immediately, right? And on top of that, if you look at this data point now, rather than the raw data that I gave you, you can actually see that this is kind of like a digital twin of the structure from a data perspective. You can see that there are environment data, there's what HVAC systems, and in the HVAC system, there's a boiler, there are some measurements, things like that. So this helps accelerate that adoption of OT data, right? Rather than the raw data where it's flat. Once, if you have done this, do it once and do it good, you have structured it very nicely, and you conform to it and you enforce it, right? The teams that are consuming all this data, they can actually not contact the OT team, and they just look at the data, they know what to do with it, right? Gives you that contextualization, right? So Litmus, right, on a technology perspective, we actually help transit our customers from their very raw file of data into a more mature consumption of data, right? We allow you to take the data, structurize it. You can also build analytics and generate real-time analytics and data and bind it back to that same data structure, right? That allows you to actually do a lot of these advanced analytics and ensure that the data is all clean and the same and consistent across the enterprise, right? And for the more advanced use cases like AI, right, you can actually run ML operations to actually adapt and iterate and improve over time, right? So that's what Litmus does, our technology does. And for the from an architecture perspective, right, we actually allow our customers to transit from kind of most of the customers today, like it or not, they have some form of connectivity. So they do have that standardization, right? So maybe they have already taken initiative to for the lack of a better word, cloudify their IT systems, right? But on the OT side, the reality is that we cannot have that kind of cloud technology that easily because of security concerns, availability, and does it make sense for us to have that component in the cloud? So from an OT perspective, typically, we have standardized things like OPC, right? OPC UA, or even if you are more, looking on the things platforms like Emission, they have Spark Plug B and things like that. But as you can see that when we ended up, what we ended up through that whole IoT wave is still a layer where we have two sides there's a clear demarcation of sides, right? From the IT side, when you pass them OPC data, they need to read the SDK and figure out how to do all that. It's not as easy to consume, right? There's still a lot of friction between the two sides. So from Litmus, right, when you implement Litmus, right, we clean the data and all that, you can actually eliminate this border, because from Litmus, what we do is that we also allow you to stay vendor agnostic, right? With Litmus platform, you can actually have full access to the data. If the IT team, for example, you're building a dashboard, you're showing OEE, right? And you want to go even deeper, you want to drill down all the way to the plant. Exactly what is the parameter in this machine that's causing these issues and the creation of the bad part. You can do that because with Litmus, we can actually collect that full stack of data flow and bind it in a meaningful way. So that's what we call the joint architecture. So we help our customers to transit, from an architecture perspective, from their traditional siloed model, or even today you have done some sort of convergence. We can even help you improve that and accelerate the adoption of the OT data. So when we talk about how Litmus does it, when we talk about Litmus is a platform, right? So we have when you buy Litmus, right, you purchase Litmus, it comes with a couple of components. So the first component is the Litmus Edge component, right? We allow you to connect drivers, contextualize and normalize the data through JSON. And we have not talked about this, but we have an analytics module that allows you to calculate KPIVs, right? As a very, very straightforward example, right, is that most of the use cases, for example, I want to calculate downtime, uptime. In the PLC world, right, they will give you a tag. And all that tag tells you is 0 and 1. 0 being off or 1 being on, right? So when you pass a raw data like that to the consumers of this data, could be AI, could be a BI tool, they have to do additional work to calculate it, right? So you then have to introduce another form of tool if the platform that you have on the cloud side or even the enterprise side does not have ETL. So that all these are just more frictions, right? But if you have Litmus, you can actually do that right within the platform itself. So we can calculate all that using the analytics module and provide you the data immediately. So so the team, and that's doing the digital transformation, they can focus on what they do best. For example, if they're doing AI, they can look at the downtime immediately and there's no concerns or any further data engineering needed on them. So that's the beauty of Litmus, really, where we can actually help you collect the data, make sense out of it, calculate things that are right at the edge so that you don't have to overload and push that role into other platforms. Do everything within the Litmus Edge platform. And for the enterprise, from an enterprise perspective, we have RBAC built-in, alerts trigger, and all that. So once the data is done, you will end up with a clean contextualized data, right? You also need to distribute the data. So when we talk about distribution, typically we're talking about data governance, right? It could be brokers, it could be some sort of stream processing, could be a Kafka engine. But you need to have some sort of data governance, right? So when we imagine if you have like thousands of Litmus Edge running, they could be producing 200 to 300K of data points per second. how are you going to enforce that all of them are in a certain formats that you have standardized? How are you going to ensure that the data is standardized and clean and accessible from an enterprise perspective? So that's the use of the Litmus UNS, so that provide the data governance, right? Of course, if you have a cloud, cloud-based or what you're using one of the hyperscalers, they may already have that sort of schema and things in place. So you don't need a tool like this, right? But what Litmus does is that we offer you that tool if you need it. And the most important thing at the last tier is that we allow you to orchestrate, and really just do mission control on all the running components to ensure that your fleet of deployed solutions are running at the best performance. So I think the deck will be sent out later on. So I will just skip these two decks. So if you are later on when you have the deck, just take a look at how each of these components within them, what are the functional elements that allow you to do what I just mentioned in the edge side. Right. So again, just as a recap, we allow you to deploy Litmus Edge and the edge side, break the data silo, create that contextualization, calculate the KPIV, and that allows you to distribute it if you need to. But most importantly, it creates the data pipeline that allows to have clean, usable data for that, so that your team that is specialized in AI, specialized in machine learning, they can focus on what they do best, rather than looking at the data and realize that they have to go back to the OT team, and then the OT has to go back to the IT team. That friction is just slowing things down. So these are some of our use cases. They are all available in our website. So feel free to go to litmus.io and look at the customer success stories, right? So as a parting note, when we talk about AI adoption, Litmus allows you to do all this. Yep, and I will hand over back to Mr. Sundar.
Thank you, Steve. It was a great presentation, and I believe Steve have shared us how basically low-code platform with industrial data ops works, especially in manufacturing industry. He have also shared with us what are the current traditional challenges that every industrial data ops has in order to pursue their journeys into adopting AI into their production floors. And then moreover, he have also shared with us how basically the OT and the IT conversion happens, and how basically Litmus can enhance that particular relationship. And I think moving forward, we'll pass the sessions to Mr. Edwin, and it is very resourceful that all the three presenters have shared a lot of use cases. So I hope these use cases will trigger each and every one of the attendees to pick it up at a starting conversation point to discuss with Vision Data team. We can explore further. Do drop us an email to set us an appointment, then we can discuss specifically use cases that you're requiring for. So for now, I'll pass the session to Mr. Edwin.
Thank you, Sundar. So
Okay,
yeah, before I begin, can you see my slides and can you hear my voice clearly?
Yes, it's loud and clear, Edwin.
All right, thank you. So okay, before I start, I would like to thank Sid from Dell, then we have Jonathan from Profit AI, and lastly Steve from Litmus. And myself, I'm Edwin, and I'm the IoT and the AI consultant for Fusion Data. So I'll be your last presenter for today. And also, before I forget, thank you everyone for still being here. So I know that it's almost the lunchtime, right? So I'll try to keep my session quick, because in Fusion Data, we are partners of Dell, Litmus, and Profit AI. And our idea is that we want to provide a solution for our end users. That's why we are combining solutions from different vendors or different partners to bring it together to our manufacturing users. And this is what we want to present, the idea of how do you achieve the concept of everyday AI in manufacturing? How do you want to make AI easily approachable and accessible to all the manufacturing users? So let me move on to the first slide. So the concept of everyday AI, right? I think you have heard a lot from events where we talk about democratizing AI. People say that we want to bring AI to everyone. But for us, when we say everyone, it's not purely the IT or the technical user. We want AI to be really usable by the manufacturing users of every layer. It could be the technicians that working on machine. It could be the engineers that is trying to solve an issue. It could be the quality teams that's addressing some quality matters, or even the development team or the R&D team that's working on new products or testing out on some new materials. So the AI for everyone really means, in this sense, for everyone. And the second is for AI, where we say for data exploration. Right now, we have most of the companies are also already embarked into some sorts of like data digitalizations. It could be using Litmus, or it could be using any kind of like solutions for getting data from machineries or equipment. And now, with all the vast amount of data, or some even in data lake, how do you transform all this into meaningful informations, or then I'll say like transform what was not noticeable or not easily noticeable to something that is you can take actions and you can react upon it. So we can use AI or machine learning to speed up this area for data exploration. And lastly, this is when, if we already starts to get familiarized with AI and familiarized with how to build models, right? We can start to incorporate models into our day-to-day life. When we build solutions or when we build digital workflows, we can incorporate the essence or the element of AI into machinery. It could be for equipments or even processes, to make it even better and smarter and more efficient. So the concept of everyday AI in manufacturing, so on the left side, right, we can see that in the manufacturing or in the factory, we get issues, we get excursions on a day-to-day basis. It could be new, it could be recurring. And also we could have ideas or some proposal for improvement, or we could even have ideas for new product development. So all of this, right, I will classify as opportunities, because like Steve and also Jonathan and Sid mentioned in the earlier presentation, right? To drive AI, we need use cases, we need opportunities to start moving. So from opportunities, that's where we talk about the data. And also we need the domain experts for each different divisions to start working on it. And currently, we really might have this tool, we have data, we have domain experts. So what we need to jumpstart this is that we need a platform where domain experts can easily use, easily access, and the data is readily available. And that's where we can churn out, or we can start to build models and train models at scale. And this is where the idea of everyday AI starts to materialize. Okay, so again, this will be a summarization like Jonathan has mentioned in his presentation. I will just condense it up into these two areas. Like, in order for companies to even embark in AI, they might already started some AI explorations or some evaluation, but more often than not, they encounter roadblocks when it comes to knowledge and experience gaps. Like the IT will focus on the IT aspects of things, the process engineer or the engineering team will focus on their core tasks. And in order to make model or AI development happens in manufacturing, these two departments or even multiple departments has to work together, or you have to collaborate very closely. And this is where it's challenging, because there'll be knowledge and experience gap between different department, intra-department kind of communications will be challenging. And secondly, some corporate or some companies might already invest resources in building up their IT or AI resources. But again, how much or how many projects can you deliver on a quarterly basis or even on a yearly basis? AI development typically takes a long time. So there'll be eventually lack of IT and AI resources to move things forward. So this is why, with the combination from Dell, from Litmus, from Profit AI, we want to share the concept of this everyday AI platform where, again, why not you train it yourself? Why not the domain experts? Let's say for the participants, you could be from different manufacturing department, engineering department. Why not you can train the model yourself, you can build the model yourself, you can deploy it yourself, you can run it yourself, and that really speeds up a lot of things. So yeah, the concept or the keyword that I would like to say is like train it ourselves. Again, this is a repeated slides, and you can see from different presenters, generally it's all the same thing. From the start to the end, we will need to go through the cycles from defining the problems, collect data, process the data, train the data. And if we were to use a conventional way, yeah, you will still need scripting, you will still need some data science knowledge, you need maybe one go for Python courses, or they go into a kind of like a machine learning development platform. And typically you still need to go through all this journey, and it's lengthy and it's time consuming. That's why not we move away, like we say, less of this, less of coding, less of effort spent in development using conventional way, which the time spent per project could take 2 to 3 months. And we move on to the concept of AutoML, where you have a problem, you have your data, you channel it to the platform, and you can get a quick results, and you can do a quick evaluation, and to get the project up and running, probably it will take 1 to 2 weeks. And later on, I'll probably show a quick use case on how this can be accomplished. So you could be in any department or the domain experts over here. You could be in R&D, you could be manufacturing, you could be sales, procurement, all the different departments. Definitely you will have some kind of challenges or some kind of opportunities, and this is where in all these domain users, right, they can directly access this machine learning platform, or we call the AutoML platform, and you can do this all on your own. Because typically right now, if you think about it, you might say, yeah, we have some requirements, or we have some challenges that we try to address, but we need to talk to IT, or we need to talk to a data scientist. So with this kind of framework, you will be able to run it on your own, and you treat this as your virtual data scientist. So a platform or this AutoML will be like your virtual data scientist assistants that will work with you to build models. And these models, again, can be in different use cases, and you can use this to do predictions, do simulations, parameter optimizations, things that Jonathan has mentioned just now. And later on, you can do your real-time monitoring, or you can even do your presentation. Yeah, this is all part of the solution. Okay, so let me move on. So next, I'll like to get the ball rolling, or to spark something, some thoughts, right? So this are some of the areas or some of the applications of the machine learning or the everyday AI. So these are the areas that quite closely related to manufacturing, and the list is not only limited to this, it can be more. But just for discussion's sake, I bring out this area like PDS, FDC, MPI, PM, virtual metrology, VM, or even companies that are looking into energy savings. These are the areas that you can approach using everyday AI. And if you are currently working on any of these solutions along this area, yeah, feel free to reach out to us. Maybe after the call, if you're interested, we can have a deep dive into specific areas. But just to spark some thoughts or some interest, these are the areas that you can consider or evaluate looking into everyday AI. Just a quick one. So for product design specification, we can use machine learning to predict the materials property, because PDS is typically a very iterative, comprehensive, and I'll say like a cycle, right? To get your from the very base prototype up to a high quality product or working products, if that meets your requirement or meets the specification, it needs to go through a lot of testing, a lot of prototyping and validation. So these are the areas where in terms of material, in terms of design parameters, validation, we can use machine learning to speed this up. And with that, you can really reduce a lot of physical testing, a lot of different combinations of material. These are the areas that you can quickly test on. And with your testing results, right, you can actually reduce the cycle, the design cycle, and also to continuously improve your products. And definitely when you run less test lots and less physical testing, you're actually saving costs for your company. So similarly for MPI, where you need to go through the pilot phase up until the full RAM or the full production, all the areas, or I wouldn't say all, most of the areas can be optimized using machine learning, like optimizing your supply chain, optimizing your prototyping, your testing, and all the validation. So these are the areas that you can quickly speed up your MPI from the initial phase up until the full kind of like production. We can look into the areas that how we can optimize it further with machine learning. Yeah, for FDC, I think this is one of the more commonly used scenario where right now we have chances we collected a lot of logs, machine logs, maintenance logs, and these are the areas that we can build predictive models quickly in terms of trying to identify the failure costs, to classify the failure costs, or even to monitor the life of the machine. So these are the areas that we can quickly work on to improve. Similarly for FDC, so for preventive maintenance, again, the same thing. If we already have all the historical data of how the machine used to behave and when is the usual maintenance cycle and all this kind of I'll call it like a experience data and also the parameters, right? We can actually build predictive models to be able to predict the RUL, the remaining useful life of equipments, and to even predict what's the failure modes and what are the potential resolutions that you can use. So again, this is, you are trying to turn all your historical data and all the human kind of experience right into a model, and you can quickly repeat whenever the same issue occurs or whenever the similar issue occurs, you can address it quickly rather than going through your knowledge base and your historical records. So for virtual metrology, this is also another area because virtual metrology, we are using parameters to try to guesstimate or to predict what would be the outcome of the value. So this also one of the areas that we can use machine learning or AI models to predict the parameters. And with the parameters predicted quicker or earlier, we can actually adjust or react to it much faster compared to before. So yeah, these are some of the benefit. And again, by using AI or as a complementary tools, right, we can actually reduce the cost of the measurement or the metrology equipments or instruments. We can improve on the process control method, and also definitely if you do that, you have a chance to improve the quality of your products. So with that, I'll quickly go into one of the use case. Like just now I mentioned more to the different areas. So now I would like to just quickly pick up an area and give you guys a run through of the platform, how it works. So the solutions or the use case that I would like to go through is on, they call it the ENIC process, which is the electroless nickel immersion gold of a PCB manufacturing. So within this PCB, there is a layer of copper, nickel, and gold. And what the user wants to do, or what the engineering team wants to do, is to make sure that the level of the thickness of the gold meets the quality or meets the standard. So if it's less, definitely quality fail. If it's more, definitely you are incurring more costs to your production. So by having the surrounding parameters, they would like to use machine learning to predict what will be the outcome of the thickness. So the problem, definitely for every single machine learning, we have a problem statement and we have like, what do we want to address? So in this case, the thickness of the gold layer is a big factor, a substantial factor to profitability, but it's difficult to control. Using the existing approach where you need to conduct UE trials, you need to have a trial and error iterations, and definitely you need heavy involvement from your senior or experienced engineer and technician, and that incurs high costs. And definitely when you have to do a lot of trials, a lot of testing, your overall productivity decreases. And the alternative or the approach that we can go for is using the AI approach, where we make use of all the data that we have collected over the years to try to build a predictive model. And we want to have a self-service portal for the engineer that is currently working on this issue to train and test the model themselves. And when he or she is able to do that, then there'll be, I'll say, less interdepartment problems or complexity, and definitely he'll be able to test it out and evaluate it themselves. So I'll say like a brief involvement from senior engineers most of the time can be focused on working on the issue, right? Rather than having meetings or coordinate discussions to build a model. So this approach will look something like this. So in this sense, right, we have the different parameters from the process and eventually the coding results, the measurement results. And all this data, depending on the company, it could be stored in different locations, it could be stored in different sensory systems, it could be in the different databases. So this is one of the strengths of Litmus, where like Steve mentioned, right, we can use Litmus to consolidate data from multiple sources, from multiple using different protocols, different areas into a single place. Then it starts to do some kind of data normalization and preparation so that it's clean for machine learning. So that's the first part. And when the data is readily available, the engineers don't even need to approach different teams and say, hey, where's my data? How do I get from my data? How do I query? All this will be readily accessible and available for the engineers to work on. And this, again, will generally like how the data looks like. It's not limited to this, but I'll just give a sample where you have all the different parameters of your machine or your process, right? And this is the results that you want to predict, for example, the thickness. And it's not limited to this. We can have like time series data, maybe what time is being processed. We could have categorical, it could be from which shift, from which serial number, and you could have numerical, like for example, the nickel and the gold parameters, and also the thickness. So the machine learning data sets can be a combination of all this. And what the platform helps you to do is you can easily upload your data. You can easily set, these are the parameters that I want to use as training. This is the target parameters. You choose and pick your algorithms on the web interface just by ticking it or just selecting it, not on coding or not on programming. This is all done, or I'll say self-service portal. And with that, you're done. So an engineering team from all divisions, right, from all skill sets, as long as you have a problem to solve, you can do it yourself or train it yourself. And with that, you are able to get the results. So once the data has been uploaded and you have trained the model, you will be able to see results something like this. And for a non-data scientist, chances are you do not want to go into details, and I won't go into detail as well. It's just that there is a certain kind of metrics or certain kind of scoring systems that people will generally use. So over here, you can see the model name is called the superstack model, and the coefficient of determination and the R square is over here. So you can see that the score is over here, and whether you can quickly evaluate whether it's a good score or a bad score. And so this score, right, maybe it will not be that useful, but then it can be used to as a proof that, yeah, this could be a good model, that this is something that you can work on further. And these are readily available for you once you have trained the model. Then subsequently, you can get the quick feature importance from there. So like, for example, based on the data sets that I've uploaded, of all the parameters, the aurum temperature has the highest weight or the highest feature importance. So you can get such information. Then thirdly is that once you have trained the model, right, you can actually start to do prediction or simulation. So you can see that there will be like a form where you can key in your parameter, things that you want to predict. And when you hit submit, you get the results like this. So all this is a user interface based or it's a web based. So yeah, you can, engineering users, right, you can actually use it right away without the need for coding or scripting. And as well as the last part that Jonathan has mentioned, let's say just now it's a prediction where you enter the X and you get the predicted thickness results. You can also have it the other way, or vice versa, where if you have a value that you want to control, or you want to like this ideal value, you can key it over here and they will return you the recommended X parameters that you need to control on during your process so that you are able to get this thickness out eventually. So simulation and parameter optimization is the results that you can get once you have built the model. And lastly is that once you have comfortable with the model and you think that it's behaving well, you can definitely deploy the model into production to do real-time inferencing or real-time prediction of your value. So you can incorporate it into your workflows or into your day-to-day processes. So this will be the quick implementation of Prophet AI. Just by having a few steps, you're able to quickly train and build model. And this aligns with what Jonathan has presented. You can build models quickly at scale. So yep, that will be the last slide I have. So okay, before I go, I'll just need to plug my company a little bit. So I'm from Fusion Data. So we have started since 2010 in Malaysia, but we support both Malaysia and Singapore. For initially, we are an IT company that we focuses on IT solutions, but then our target customers is all this while is always manufacturing, but we also have oil and gas FSI as well. Then over the years, we expanded to new or quite emerging technologies like cloud solutions, cybersecurity, web, and as well as OT, where we work on data acquisition, factory automation systems, and also web reporting. And in 2017, we start to go into AIoT research. This is where we start to evaluate solutions, for example, like Litmus, right, and also Prophet AI. And in the year of 2022, we start to partner with Litmus, then after that, Prophet AI. And that's where we bring the solutions together to our customers, because we do not want to bring like a individual pieces. We want to provide like an end-to-end idea where you have your data ready and all your data are ready to be used. Then you have Prophet AI for your engineering users to build model themselves, and all this we run it on Dell because we have been partners with Dell for a very long time, since the beginning. So it's a journey along the way, and definitely it doesn't end there. And right now we are looking even further to having large language model, or we call it generative AI, bundled into our solutions. But yep, there'll be a session for another time. So yep, I think just now I promised a quick demo. So I think I still have a few more minutes. So let me just quickly bring up our lab to show you how the model training can be done quickly. So you'll just take a couple of minutes. So let me just switch you over there. Hold on, yeah, let me just quickly bring up my screen. Yeah, there you go. Okay, so I hope everyone can see my browser. So this is the interface for Prophet AI, and it's accessible using the web. So when you log in, you will see a page like this. So I'll just quickly run through, and if you have further questions, right, you can always reach out to us and we can have like a full scale presentation and demo. But right now, I'll just show you how quickly we can build and train a model. So first, definitely you need to upload your data sets, right? So I'll just say data set 30th of July. Then I have my sample data sets. So I'll just pick one. Confirm upload over here. So the first step is always to upload the data sets. So what it does behind the scene, I'll show you it'll take some time, but I'll show you the demo one that I have done before. You will just do a quick check of all your data sets to make sure that it's good for machine learning. Chances are you don't really need to bother with all this, but this is what it's doing for you, like doing some kind of mathematical calculation to ensure that your data is good, or the quality is good for training. Any missing records, any unique records, any suggestions, you'll provide to you over here, as well as the heat maps and so forth. So once the data is confirmed to be uploaded, like, okay, you can see that it's done. It's the same thing. So once the data is uploaded, the next part is to train the model. So training the model, I'll just say like train or maybe I say predict thickness, 30th of July. And I pick the data sets that I've uploaded. I select the target feature, thickness. And these are all the training features. Maybe if I want all, I can select all. If not, I can disable or remove some of them. So in this case, I'll just select all. And yeah, this is what I mentioned earlier in the presentation. Everything is done via interface. Next. Okay, so the next part again is I mentioned that you can go for auto mode, means that you do not need to have machine learning knowledge. You can just run it directly and go. But I'll just quickly show you, if you want to be very precise, you can tune all this. Again, this is more to someone with a data science experience. You can do the tuning. Then you can pick the models over here. So instead of running it independently one by one, you can just, maybe I want to run this, I want to run this, I want to run this. Then you can run all these models and do a comparison. And if I hit submit, it will start running. So instead of that, maybe I'll just go into a mode where I go auto mode. Means assuming that I have no knowledge about machine learning, I just want to see what kind of relationship my data can bring me, or some kind of insights. I can just go auto mode. Next. And here I can leave it to default and submit. Yep, so that's pretty much it. And it will start to build behind the scene. And once it's done, for example, this is the one that I've executed a few days ago. Once it's done, you will be able to see the models. Like, for example, I ran using 7 algorithms. You can see the score over here, whether is equal. So you can see that some is not really performing well and some is better. So if I can find a good one, or maybe something that's better, I can start with this, for example. Then the feature importance over here, and all the other supporting materials. So some might not be very useful. You can use this for starters, like this, like the orange temperature will be the feature importance. Then with that, you can test on the simulation over here. Like, you will see what I've shown. If you enter a certain parameters, let's say if you want to change the pH to 4.12, the thickness will be affected. So yep, you can test with different parameters, and you can see how the result is being predicted in the simulation. And lastly, on the parameter optimization, it's the same thing. I will not run it down, but I can just show you an example. So if we have a value that we want to fix, or you want to get, for example, this value, and these are the different parameters, right? If I enter 0.44, it will return to me the values that I need to control on my systems to make sure that I can achieve the target. So it's like a suggestions back to you. So this is another way that we can use the platform for parameter optimization. So the earlier one is be more to predicting the results, or the why. This is when you want the why, or you want to target the why. What are the parameters that you need to control or tune? So yep, generally that's it. That's a quick introduction. Definitely we have more things that you can explore on the platform. But generally, for starters, if you want to build models, find a relationship of your data, you can do it. And that's where you can start to build different use cases. It can be from different sectors of manufacturing. So yeah, I think that concludes my sharing. Definitely we can go into deeper, but because I ran out of time, I'll stop over here. I'll pass it back to Sundar. And if anyone is interested, yeah, feel free to reach out to us, and we can definitely bring this forward further. Thank you, and I'll pass it back to Sundar.
Thank you, Edwin. I think that's a very detailed presentation on how Fusion's Data Everyday AI platform works, and I think the demo that you have showed should give a very good confidence for all the audience here in order to try to engage us, in order to discuss further how basically they can kickstart their everyday AI initiative in their industry. So moving forward, I think we are moving towards the end of the session. Yeah, once again, if any of the audience have more questions, we will address all the questions towards the end of the session. So I'll move to the towards the end of the session. First of all, thanks once again for all the audience that still keep they are still with us, and we are looking forward to have more sessions, more webinar as such in the coming time frame. Do let us know if you also have any other perspective or angle that you want to, or any use cases specifically that you want us to conduct in the upcoming webinars. We can do that. We can incorporate more use cases specifically for any specific industry or process in manufacturing. So just as a summary, maybe I would like to summarize of what we have presented today. So I believe our speakers have given you a very in-depth understanding in accelerating your AI adoption into manufacturing operation. So as mentioned in the beginning of this webinar, we have highlighted few key takeaways, and this slide basically summarize of how all our respectful technology partners plays their role in assisting all of you to gain AI citizenship with that belief, where we have all the 4 key speakers from their respective companies. Dell has presented their modern data lakehouse initiative towards materializing AI factory initiative, even being fundamentally known for DC infrastructure or software hardware provider. I believe Dell's AI technologies has elevated them to be part of this AI citizenship journey. And as all the presenters keep on mentioning, I believe you guys have realized each and everyone have mentioning about data. I think data, or the amount of data, plays a vital role in your industry or in your environment to kickstart your AI journey, especially. We believe every manufacturing industry have a different sets of machines and data set formats. So that is where Litmus plays a role in accelerating that process of data collection and also contextualizations. And so once all these data sets has been cleansed or contextualized, that is where the next puzzle, which is our Prophet AI's virtual data scientist, is adding more gears into the process of accelerating in building and training AI models, and indirectly or eventually improve your AI strategy to be a successful AI citizenship. We believe all use cases, I think the use cases shared by Jonathan are pretty much very specific to customers' problem, and how Prophet AI able to speed up the process of model creation, optimizing it, and deploying it into the production with their modernized AutoML solutions. And then we have Fusion's data. We believe all the key pillars that we have mentioned, be it from Dell, Prophet AI, and also Litmus, needs an experienced subject matter expert in puzzling up all this puzzle. So we at Fusion Data align to that strategy of AI citizenship with our everyday AI platform. And we will be our primary technology consultant between customers and our product principal in materializing this journey. And once again, we hope today's session has given you a very broader perspective, more insight, more use cases, more examples, more ideas to every one of you to kickstart your AI journey, or to adapt to AI initiative in your environment. So with that, I think we have questions from the audience that we can look into. So let me look at the chat boxes. Chasin, probably you want to read all the questions that we have on from the audience.
Hello, Mr. Sundar.
Yeah.
From the chat box, I see a majority already replied by our team.
Okay.
To the audience.
Okay, so maybe just for the sake of everyone's reference, probably you can just read the questions and the answers provided. So at least everybody can gain the benefit of the answers.
Okay, sure.
Yeah.
We have one question from Ms. Jazz. What if we have equipment that Litmus don't have the driver available? How do the equipment to Litmus to extract the data?
Okay. And this is answered by Steve.
I'm sorry that this question haven't been answered.
Okay, so probably I think,
about
yeah, I think probably Steve or the rest of the members will be able to answer that.
While Tim is preparing, maybe I'll skip to next question.
Okay, cool.
Okay, we have another question from Mr. David. Who do I contact for more information on the commercial side? For this question, I already replied on behalf. Feel free to send the inquiries to low-attribution-data-sb.com. We'll be very happy to assist.
Okay, okay.
Okay, next question from Mr. Gobi. If I have a use cases at this point in time and have a reasonable amount of data, how long will it usually take to create a model from testing till deploying the model for production? This question was replied by Miss Jenny.
Okay.
Actually, if you have the data and the topic already, you could use Prophet AI to build up models within a few hours. And if the model result is good, the models could also be automatically packed and ready for deploy.
Oh, okay, that's good. That's quite fast.
Another question from Mr. Gobi. How can we go about to get vision data or Prophet AI consultation team to work with us if to come up for potential use cases if we already have the data in hand?
Okay,
The
that's a great
question
one.
also replied by Miss Jenny. We have experienced consultants in various industries and we work closely with our clients to discover possible AI opportunities.
Okay, okay.
Audience can contact us for specific use cases for your industry via low-attribution-data-sb.com. Okay, another question from Mr. Harris.
Yes, Mr. Harris.
I have an AI model in training. However, its performance slip-through rate is not yet at an acceptable level to be deployed. Is there any tools or platform available that can help me to easily improve the performance? The question was replied by DC.
Okay.
Prophet AI can automatically build and improve AI models, so I believe this tool would be helpful for you. However, the final model performance still depends on the data quality. Hence, Litmus could be applied in collecting more useful data.
Okay, so that's where how the puzzles work between Litmus, Prophet AI, and also everyday AI platform from Fusion. Okay, that's great.
That's all from chat box.
Okay, okay. Do we have any other questions from the audience? If you have, maybe we can just unmute yourself and ask us, or if you want to type it in the Dropbox, feel free to do that. Okay. Okay, so once again, thank you very much. Thanks for the time that you have given to us from 10 a.m. in the morning itself until now. We are in between of your lunch time. But before you guys leave the sessions, we have a number request. Please give us a feedback or even details of what you guys want to see in our upcoming webinar. Maybe we can take your inputs in order to basically enhance or to make our upcoming webinar more interactive sessions to you guys, and precisely to be very resourceful or specific to your particular process industry. So please drop us a small remark or details or feedback in the chat box before you leave. So thank you once again from our team, Fusion Data, Dell, Litmus, Prophet AI. We hope to see you again. Definitely there'll be another upcoming webinar in the future, and looking forward to see all of you again once again. Thank you then. Thank you. Thank you. I can see a lot of chats going on. Thanks. Thank you once again to all the audience, and thank you very much to Dell, to Sid from Dell, and to Jonathan from Prophet AI, Steve from Litmus, and also the rest of the teams from the principal company. Appreciate your assistance today. Looking forward for more webinars in the coming future. Thanks once again.